This is the development PowerPoint for the non-durable doggy toys. My parts list are 12 ceramic magnets, cotton fabric, stainless steel chainmail, polyester thread, polyester stuffing, and 1-inch squeakers, which is optional, but I use 2. My tools and equipment are a sewing machine, fabric pins, sewing needle, wire cutters, scissors, pencil, and the estimated build time is about an hour to make one piece, and then for the completed toy is about 6 hours. So first, I drew the fabric pattern and cut it out on the fabric base. Then I sewed the fabric together using the sewing machine. I cut off the threads after I was done tying them, and then I stuffed the fabric base with the polyester stuffing. Then I created 2 magnet holders with the stuffing and the magnets. After that, I put the magnet holder inside the fabric base and sewed it together. Once the second magnet holder is attached, it should look like the picture in the top left, which is the completed fabric base. Then next is adding the chainmail. I wrapped the fabric base inside of the chainmail and used thread to sew it together, and I tied each individual link instead of connecting them all together. Then I cut off excess pieces of the chainmail and then continued to sew it together one by one. Then when it is complete, it should look like the picture on the top left, and after repeating the steps 5 more times, you should get a completed toy of 6 pieces, just like the picture in the bottom left. I first planned to use a one-piece pattern for the fabric, but this resulted in a piece that was too small, or when I did the bigger version of it, it was lopsided and the shape was not desirable, so I ended up using a 2-piece oval pattern. I first tried using metal beading wire to sew the fabric base together, but it did not work because it wasn't strong enough, and as you can see in the top right picture, that the stuffing and the fabric was already coming undone, which was not very strong. Then when I was sewing the magnet on the inside, it was very hard to do without adding anything to it, so I created the magnet holder to help keep it in place and make it stable. On the picture on the right, I tried 2 different ways, which was sewing it on top or just sewing it in the inside, and the one where it's sewn in the inside worked best, and I used that for the final design. I also wasn't sure how much chainmail to use, so I experimented with the lengths and determined that for every piece of chainmail I had, 2 fabric pieces could be wrapped. And then the chainmail was supposed to use the excess links to reattach to each other, but this was too time consuming and too hard to do, so I just used the thread to tie them together individually, as if they were chain links, just thread. So the finished prototype should be 6 pieces in total, and it's the chainmail that surrounds the toy, the fabric that covers the inside of the toy and holds everything together, and the magnets that are inside the fabric that connect each of the toys together. Here is the video that shows how the magnets in the toy attach, but it can also be detached if needed to. The test I use to determine the durability of the toy is a PSI test, and like at the picture on the right, we have 3D printed teeth that would surround the dog toy, and you would be pushing it on a 1-inch squared area of a cube, which is on the scale to show the pounds per square inch, and the minimum that would be tested is 200 psi, which is the average bite force of a large dog. Here shows the 3D printed pictures of the dog jaw and what it looks like, and then with the toy inside the jaw right before testing. Here's the picture of the testing with the clamp being pushed down on a metal ruler on the toy with the dog toy inside of it. We used a metal ruler because we changed the square inch to be more elongated but still equal a square inch in area. But in order to push down and the total area of it, we had to use something that could cover all of it but is still strong enough to withstand the pressure, so we used this metal ruler. Here is the video for the 250 psi test. As you can see, it hits 250 pounds and then it is unscrewed. And then when the dog toy is removed from the dog teeth, you can see that there's no damage to the chain links or the thread tying it together. This is the 350 psi test, and as you can see, just like the other one, the scale hits 300 pounds, and we unscrew it, and the dog toy is removed again, and it is undamaged just like before, and the thread is all intact. So in conclusion, after being tested 3 times at 250 psi and being tested once at 300 psi, there is no visible damage to the dog toy, and this proves that the toy is durable enough to withstand a dog's bite. As far as future design changes, I would like to use stronger magnets because the magnets I use, they do hold the toy together, but if they are bumped, they can easily be removed, and I want them to be a little bit stronger. I would like to add the middle/frisbee portion to the toy as shown in earlier design sketches because I feel like that would be another good way to entertain the dog and the owner since they can throw it and they can go fetch the toy. I would also like to use a waterproof material for the fabric base because large dogs tend to slobber a lot, and I know the owner probably doesn't want to deal with that, so I would like to get rid of that problem altogether. And last but not least, I would like to have a special thanks to my father and mother who helped me through several parts of this testing, and then my teacher, Mr. Gomez, who is my course instructor who has answered my many questions about this project, and my physics teacher, Mr. Calderon, who helped me finalize the testing method for the dog toy. And then these are my references. Thank you.